Hi everyone and good afternoon to everyone. Hope you guys are enjoying Stack so far. So today I am Yong Jian from DSTA, Defense Science and Technology Agency, and I'll be asking the questions of do we need robots? So what we do here at DSTA is we develop and architect different robotic systems. So hopefully I can give you a keen insight into our decision processes. So first of all, the world we live in today is a very bipedal world that is very much designed around a world of legs. We have things like curbs, with stairs, things that get in the way of handicap access. And if you look at our natural world, you see that we are inspired by a lot of animals around us. Besides the occasional snake that we get, most of the animals are either four-legged or six-legged or two-legged. So that brings us to the question of why, when we look at robots today, why are they traditionally, conventionally wheeled or tracked vehicles? In this case, we see people trying to develop new kinds of experimental robots like jumping robots or slithering robots. A decade ago, if you asked me whether legged robots are possible, I'll tell you that this is just a simple lab experiment. But today, we see rapid development in this space, and we get a lot of different companies from all over the world that are steadily developing these quadrupedal UGVs. So what are the features of legged robots that we look out for, and how do you define a legged robot? First of all, the very important question we ask is how many legs do we actually need? You might be surprised today that there are robots out there with one leg, something like a pogo stick for a jumping robot, all the way up to an octopus kind of robot with 8 different limbs. They are maneuverable underwater as well. Furthermore, the way a robot walks with its different gaits actually defines its use cases. For example, the difference between a bipod walk and a tripod walk can change the speed and the use cases of a specific robot. Finally, a robot is able to see as well as feel the world around it. It will allow it to travel much more efficiently. This can be done through a variety of means, either through vision or the ability to feel the world through its legs via either a current control or some sort of motor controller. So with all this, what kind of advantages do we get from having legged robots? First of all, we know that legged robots are significantly more maneuverable. They are able to rotate on the spot, they are able to walk like a crab, and they are able to go in much tiny spaces as compared to either a wheeled or tracked robot. Furthermore, such robots are much more stable. As you can see from the demonstration, that it's very easy to kick it, and they're able to get up easily. If you guys are interested in having a look at a robot, we do have a booth over there where you are able to experiment with the robot as well. However, this definitely comes with its challenges. First of all, a legged robot is much, much slower. Unfortunately, it's currently in the market, we see that they're limited to around 10 km per hour, and this significantly limits not only the range that we get, but also its ability to respond to situations. Furthermore, compared to a wheeled or tracked robot, the ability for a legged robot to carry weight is significantly lesser. This reduces the amount of payload that we are able to carry, and also reduces the amount of things that we're able to use it for. Finally, battery life is a significant constraint for us. Even though we are looking at 1 to 3 hours of usage as compared to maybe a drone, which is maybe 30 minutes, a wheeled or tracked robot is able to go much further, going up to maybe about 7 or 8 hours. So this is the kind of constraints that we face. So what then are we looking out for when we decide if a robot should be legged or otherwise? First of all is the environment that it's in. In this case, is a legged robot better able to withstand the unearthness of the terrain that we go through? Is it able to be waterproof? Can we use it in the rain? Next thing we look at is about transporting a legged robot. Because it can significantly less range due to its battery, we only need to transport it somehow towards our area of operations. So this means that we need to find other vehicles, or we need to find other modes of transport for our robots. Finally, the infrastructure is a severe limiting factor for us. Because of these kind of robots, you require a lot of charging stations, you require infrastructure along the way. Today, our infrastructure are not built with robots in mind. They are built with bipedal humans in mind. Therefore, unless we shift to a perspective where we are able to integrate all this infrastructure into something that we're able to use, we are not able to fully harness the power of a legged robot. Finally, what's next for a legged robot? First of all, we want to see that robotic arms are steadily being developed. So no longer are we looking at a robot with 4 legs. We are looking at a robot with 4 legs and 1 arm. In this case, this 5th limb can be used for a lot of useful things such as removing rubble or opening doors. We are also exploring things like platform autonomy. A robot on its own today can be used by 1 person, but imagine if a swarm of robots are being able to harness by a single person. Finally, we are also exploring very novel mobility and delivery methods. For example, today a robot is able to walk, but what if our robot is able to fly and our robot is able to swim as well? With that, I'll come to the end of my presentation. As I mentioned earlier, we do have a booth earlier, so if you guys want to give it a try, please come on down. And when I asked, do we really need robots today? I think the answer is we don't know yet. And right now we are still experimenting and trialing, and we hope you join us on this journey. Thank you.